The muon is a subatomic particle that belongs to the lepton family, along with the electron and neutrino. In this video, we will explain in detail the aspects of the muon, including its basic properties, lifetime, interaction, applications, experiments, and discovery. Basic properties. The muon has a negative electric charge equal to that of the electron and a mass 207 times greater. Its spin is half, which means it has a quantum property associated with angular momentum. Lifetime. The muon has a lifetime of only 2.2 microseconds, which means it decays very quickly into other subatomic particles. This lifetime is relatively long for a subatomic particle, allowing it to be studied in laboratory experiments. Interaction. The muon interacts with matter through electromagnetic and weak interactions. Unlike the electron, the muon also experiences strong interaction, which is the force that holds atomic nuclei together. Due to its greater mass, the muon has a shorter range than the electron in material media. Applications. Although the muon is an ephemeral subatomic particle, it has several applications in science and technology. For example, it is used in muon tomography to analyze the density of opaque objects such as concrete and metal. It is also used in material studies and particle physics research. Experiments. The study of the muon has led to several important experiments in particle physics. One of the most well-known is the MUON G2 experiment, which measures the muon's interaction with a magnetic field. Other important experiments include the discovery of parity violation in muon decay and the observation of muon decay into an electron and two neutrinos. Discovery. The muon was discovered by Carl D. Anderson in 1936, while investigating cosmic rays in a cloud chamber. Anderson observed a particle with a curved trajectory, suggesting it had an electric charge, but its curvature was too great to be an electron. After investigating its properties, Anderson concluded he had discovered a new particle, which was later named the muon. Conclusion. In conclusion, understanding the muon is crucial for advancing our understanding of the fundamental structure of matter, the interactions of subatomic particles, and the fundamental forces of nature. Additionally, the muon has practical applications in medicine, such as muon tomography, which can be used to detect diseases like cancer. Overall, the importance of knowing about the muon lies in its key role in particle physics and the practical applications it can have in medicine and other areas of science and technology.